All right, we're back. We're back, fully rested, and ready to really finish this time. Okay. Thanks for watching the series, DiSco-MIMO. You know the story. We're pretty much done with the plots, almost done with the code. Okay. So final goals for today is to let me add this nice plotting box here. Okay, so we'll finish the nice plots today. And then in one, if you're watching on YouTube, in a very upcoming or coming soon episode, we're gonna write a new paper. If you're on stream, this is gonna happen today. But yeah. So pretty good, right? Yeah, so we're also gonna write the paper on this channel or on stream, wherever you want to watch it. Thanks for watching, thanks for the follows, subs. So let's get back to it, right? And this is kind of already, we're close to writing, right? Because the last thing I want to do about the code is I'd like to, whenever I write the paper, first I like to have all the figures and all the results ready, right? So that's why today I first want to finish, in this episode, I want to finish the remainder of the plots. It's going to be a short paper, 4 pages. So we only need 3 figures and 2 result figures and 1 block diagram. Okay. So we just need 2 result figures. So let's get back right to it. And actually the plots has already become this sort of a sub module by itself. Because what I want to do is I just want to be able to run UV run plots and all the plots happen. One of them is kind of there today, so I call it pentaplot because we're going to plot 5 curves for the paper. Because remember, we were able yesterday, or in the previous episodes, we were able to reproduce the sort of the sampling twice so that it looks nice. But when we actually try to measure how good sampling is, the results are mixed. So we're gonna have to write a paper about this. But first, let's make this plot better because there are 5 data sets here that I'm trying to show. I'm trying to show 2 training data sets, the first 2 curves, and then 3 synthetic ones. So maybe the first thing I want to do is I also need a line marker for this plot, okay? Because I want to plot them differently. So where is plots? Line styles, right? So we'll have dash, 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 and the synthetic data can be continuous, okay? So then we'll also take these line styles. We're gonna customize the plot as much as we can. CDF, so it'll take line styles, list of string, and we'll say for line style and line styles, and I believe the plot is, yeah, it's line style equals line style. What else can we make here? We should set the global font size, and I think it's RC params font size. We can go higher. We should go like an 18 or something because we want the plot to be nice and large. We should not override this font size then. Cumulative distribution function is fine. Maybe a bit thicker lines. We can add markers. but we don't want to add markers. No limit, let it pick its own limit. Location best, sure. DPI 300, box inches tight. Let's see how this looks like. And the other plot I want to make, so this is one plot. The other plot I would like to do for the paper is plotting the training curves. Let me see how this pentaplot looks like. Kinda there. Font size is good. Okay, the font size is way too large, and also the legend font. Does the legend not have a font size? It doesn't. So I need to look at this up then. Matplot, lib, legend, font size. Oh. Okay, so let me just do it per rams then. Well, actually, no, wait. So can I not just do... I can't do font size to this. Damn it, I really don't like this thing. Maybe I can. Okay, this looks a lot kind of better. So we have 2 training data, 3 synthetic data. This is clearer now. But this legend looks ugly. So why don't we give it a bit more white space on the right, and then put the legend center right. So plt dot. Okay. So matplotlib split label in legend across new lines, because I have an idea. Okay, so it should be dash n. Okay, so here's what I want to do. What if we split the legend? So we do dash n, training data. What if I give it a bit more white space? So set x lim from 42.5 to 80. And what if for the location I pick right? What locations do I have? Center right, PLT legend location. Is center right possible? Oh yes, it is. Center right. And I gotta shrink it a bit. Font size 12. Now, because the reason is my paper is the template is a double column template, but it's still a bit wider, so maybe I can still use a let me see what's happening. How does this look like? Okay, it's looking good. So I need to cut synthetic data. Okay, it's kind of getting there, right? So we can also boom synthetic data, more space. Let me give it a bit more space, an 85. This should do it. Okay, what do we have here? Okay, starting to look pretty good. It's kind of there. Just push it just a bit. Come on. I can make the figure wider a bit. So if I make it a 7/6, how is this gonna look like? I think this is it. Just a bit wider because I think it works better for the format too. Let's see. Aha, yes, I think this is it. Okay, good, perfect. So we have 5 curves. And these are the results. We'll have to write about them. I would say this is a pretty damn good figure. So I can just upload this to the paper. So here's the other thing I do is now let's go to the template, which is in latex. Okay, we're gonna have to talk about this tool, but this is the template of the paper we're gonna write. And what I do is I keep a figures folder. I'm just gonna upload it. Where am I here? Score based. Disco. Because I want to see how it actually looks in the paper. So it's called Pentaplot. Okay, it's taking a while. There we go. All right. And where is the sample image? Oh no, Franklin, what is it? Okay, so then finally we don't need this. Pentaplot. We don't need a description. My whole point is I want to see how it looks like in the paper. It looks pretty good. I gotta tell you, this is readable, right? So what I'm looking for is the font size being the same size as that of the paper. Possible image without description. Not sure what this is. Oh. Oh, I see. They want you to... Okay, this is something new. It's for accessibility. Okay. Description. Okay. Okay, other things we can do. What should we do here? I don't know. We can't make the font consistent. It's too annoying, right? Probably. This looks pretty good though. Looks pretty high resolution. We could make it a PDF, but then there may be some other rendering issues. Let's leave that for more latex work. I think I'm pretty happy. This is one of our results, basically. We're gonna have to write around it or comment what the heck we did here. Actually, it seems we're most successful in... No, we're pretty successful in generating synthetic data, right? The orange and the red curves, they should be close to each other. The original paper has more issues, but it's because of its sampling. Okay, we have a lot to talk about. Good, in the paper. The other paper now, before we start writing, and after this, we're kind of done with the plots for good, right? So we can call this nicer name, CDF plot, okay? The other paper I didn't do yet, because the other plot I didn't do yet, but it's a bit easier because so let's just load. I want to load the loss curves too, right? So we're gonna return a tuple because we have everything loaded anyways, okay? And we will say loss is numpy as array. So what did we call the loss in our training code? I believe we called it train loss log. Okay, and this will be a float 32, and I don't remember what is it called here, but we can just breakpoint and find out what it's called here. In the legacy code. So basically I just want a basic training plot to show that both the reproduction and the original paper, they go to that mythical about 100 value we saw. What do I have in contents now? Oh, I know, I see. I don't have it here actually. Oh shit, I can't do this here. I'm gonna need a new function. Because the loss is load loss. Very annoying, but we have to do it like this. And the reason why we have to do it like this is that the loss is in a different H5 file, unfortunately. So if use H5, okay, so loss will be loss. Okay, what do we say this is? And then loss will be something, none. We'll have to breakpoint here. What is the loss here again? Train loss log. And it's a float 32. The only problem is we're gonna have to load the loss. Okay, so now to plot training curves, we shall do the same thing. So if the length is not the same, then 4, we're gonna load the data. Okay, so we'll say if the length of paths labels is not the same, okay, we're gonna plot the figure, and we don't need to transpose anything here. Maybe we need line styles. Probably not for this one. So then we can say loss. Okay. And then we just have to plot it actually. So it's the X will be range from 1 length of loss plus 1 loss, label, line. Okay. Then we just have to wrap up the plot. So we wrap up the plot, title, training loss, exponential moving average, step, the legend we can leave up to a best. Let's not do the limits, tight layout, close. Good. So then what we have to do is we have to call plot training curves. Now the training paths are different, okay? So training paths are, because unfortunately the loss is found in the model file. Oh wait, which is also true for me actually. Wait a second. So there actually there's nothing wrong here. So my thing will have models too, because ours will be models paper. Okay, CDLC / weights step 124799.pt. The second model is, okay, so we're gonna need training paths. What do we want the labels to say? Original training, refactored training, training labels, and what else do we take? Oh yeah, uses HDF5, true false, and name training.png. Okay, so the only thing is we need to figure out where the heck is the model, because it's in up, score based channels, models, score, CDLC, final model. Model, score, CDLC, final underscore model. Model scores is it, final underscore model.pt. Okay, and I should get exactly the same. The only difference is I need to finish. I don't know how to load the loss here. So let's let this run now. Okay, so pre-commit run all. Missing word. Where do I have line styles? Missing plot CDFs. So CDL. Oh, sorry, I broke CDL. Yeah, because I changed my plot code and I use it in CDL2. Line styles. Continuous. Okay. Pre-commit run all. We're done here. All right, so chop gotta run the plot. So UV run group torch plots. Okay. Let us see how this looks. Aha, it's a torch actually. Oh, I see. So the training is always a torch, is it not? Yes, it is. Good, very good. So it's always torch load. Map location is CPU. I'm gonna do a trick here. I'm gonna leverage UV even more. Legacy, right? So if it's legacy, we'll have to breakpoint. Otherwise, I know it's contents. What was it? Oh, okay, here it is. Train loss log, which I believe is already NumPy. So the thing is, if I import torch here, I'm gonna have to delete the, that's okay. I'll delete the plot from the CDL. Oh, did I say load? Sorry, I meant load loss. Legacy. Is legacy. Legacy. Interesting. So I need dot map too then. Okay, it's not the worst. UV add dot map, because I can't load the legacy data. So many damages done by. So let's see, what do I do with dot map now? Okay. But can I sync to group torch? I believe I can, yes. Actually, I should remove this score SDE PyTorch. Forget about all this. Okay, so UV lock. UV sync group torch. SciPy. I gotta add SciPy back. And let's see, UV lock, UV sync group torch. Let me delete this then. We don't need the plot from here. Let me clean this up a bit. So cfg dot verbose. Okay, so pre-commit run all. We can remove this. And sync to group torch. And UV run group torch plots. Yeah, so I still have the NumPy issue here, so I need this line back. Interesting. This is a silent, I mean, there must be a reason why I added this, right? So UV lock, UV sync group torch. All right, again. Good, we're done now. So what I finally was able to load the legacy file. So length, contents, train loss, I believe it is, right? Yep, so loss. And is it like, let's see what this is. It's just a list, I guess. Nice. So UV run group torch plots. Finally, the second paper plot, come on. Okay, so we plotted, what would they call it? Pentaplot is the old one. What's the new name? Blah, 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 blah. CDF plot, perfect, and training. Aha, we have to smoothen this. We have to smoothen the, because we EMA with 0.99, right? Zero for value and loss from 1 onwards. We're gonna append the previous one times 0.99 plus value times 0.01. So we're gonna smooth this curve out to raw loss, and we're gonna call this loss, raw loss. Okay, that's because we do in our train loss log. Yeah, we do a trailing loss. And it starts from that one, 0.99. Okay, good. So let's see it again with that one. And what else do we need? What else can we mess with this in this plot? Label font size can be larger here. 16. Should we do a Y scale semi-log Y? Let's try it. Let's try a Y log scale plot because it does look a bit distorted, right? We want to see some of those details. Oh, I can't wait to get it. Okay, let's see how it looks. Looks pretty good. Nice. So we're able to reach lower. Can I do a grid fine, which both and I think I want that stronger alpha because I really want to see those grids. Very interesting result. So we're able to reach a lower loss. Now the training data is different. So yeah, it's hard to say. We're gonna have to comment on this. Okay. All right. Interesting. Should we do a double log plot? Like log? Something interesting is happening here. We're reaching a lower training loss. But it is what it is. We're just gonna have to write the paper around this. So good luck to us. Not enough time to consider this anymore. Yes, I like the log plot. Okay, this is the plot. Good. So training and CDF plot. I think we're actually done. Okay, so pre-commit, run all. Let's commit everything we changed. We also messed with the dependencies a bit. We simplified them, which is also good. UV lock, git status. So we changed git add plots, PyProject, UV lock. And what else did we change? Oh yeah, we changed, we simplified MIMO CDL, commit, final plots, and simplifications. And I think it's time we freeze the code for a while and get back to writing for like 2-3 hours. And then we'll see where we are. Okay, so we can push this upstream. And that is it. Let me merge this in DiSco-MIMO so it's all in public. Looks clean. Okay, we go git checkout main and pull it. That's it. Let's freeze it. Stop. Okay. All right. So we're done. So now we go to the paper and we upload both plots, which are called training and CDF plot. And we remove the sample from the template, and we also remove the badly named penta plot. And we go to the main file and we use CDF plot, and we also use this other one. And this one is called, oh yeah, we need a label for the figures, but we'll do, okay. Fig CDF, label fig train, okay, and this will be training. Let's see how they look in the file. They're looking pretty good. And that's it for the two figures. We're done with the code. Before we move on to the paper, well, this is a good time for a break. So we can cut the, yeah, we can stop here for now. If you're watching on YouTube. We gotta do one more figure, the teaser figure, which shows the whole diagram for the paper. And then we're basically writing the paper. So thanks for watching and follow along. It's happening soon. Quick break, end of episode. Thanks for subbing, thanks for following. I'll be back. All right, we're back with more DiSco-MIMO, very close to the end now. Let's get right back into it. Thanks for watching. Thanks for sticking around. Welcome. We did plotting last time. We finished the plots. We finished the code. I'm not going to touch the code unless it is to refine the plots, okay? We're going to write the paper now. Well, one more difference. I want to make a diagram for the paper. And then we're going to start writing, okay? So, like I said, I usually like to have all the figures ready. And I just write around them and write the methodology. So we'll do all that. And this is the template, right? I think it's also a good time to say what this is. So it's a conference ACM rep. It's a small conference focused on reproducibility and replicability, which, you know, spanning traditional blah, blah, computing applications in sciences. The conference values submissions that demonstrate reproducible experimental results where full reproduction is not achieved. Detailed documentation of the reproducibility experience is equally valuable. So this sounds suspiciously like the whole DiSco-MIMO series, which is really good timing, right? So experiment portability, software packaging, there we go. We're gonna talk about UV, approximate reproducibility, data versioning, we had a lot of trouble, automated experiment execution, we did that too, computational infrastructure, reproducibility experiences, sharing and consuming, hackathons, campaigns, broader. We did a lot of stuff that's relevant. So we're just gonna write the short 4-page paper, okay? So this is the template. And we already have 2 figures. So what I'd like to do now is I'd like to do what they call the teaser figure in this template. And then we're just gonna start writing it, okay? So now the teaser figure is this, but we don't have it. It's gonna be like a big front page figure, okay? So we need this. So let's draw something in Excalidraw actually, because we've been drawing it. Oh, I can actually close the code for now. So let's draw a teaser figure. What I'd like this to show, so what do we want to convey to a reviewer? How do you convince a reviewer instantly? Well, I like to have on the left side the old code and its messy dependencies and hard codes. And on the right side, the new refactored code. Okay? So on the right side, we'll have loose scripts. What did we have, right? Which we can maybe, how should we mark this? Let me think a bit. Design is very important here, right? So we had a train_score.py. Train.py. So we didn't have Python modules, right? So let's call this non-modular. Okay, so we had something non-modular. That's one negative we had. We also had a requirements.txt. Linux only. What else do we have that was bad? External repo hard copy, which was really bad because we ended up hard copying that NCSN v2 repo, right? Hard coded values and no CLI, so no command line interface to change them. What's another negative that we had? I feel like these should be swapped. Hard-coded configs without CLI. So no CLI, no command line interface, loose scripts. And paths. What's another negative that we fixed? Oh yeah. MATLAB dependency. So this is another big fix, right? I think this is enough for what we fixed, okay? So how does the new world look like now? The new world looks completely different, all right? It has a Pi project TOML, pre-commit hooks, and Python module, and it has rain sub module, sampling submodule, plot submodule, or we can put etc. here. Dot dot dot. Okay, but this is a dependency group, very important, right? So this will be send to back. No. Bring forward. Oh, come on. Oh, I lost this thing now. PyTorch dependency group. Okay. And the other one is Siona module, data generation module, and this one has, let's see, let me pull this bring to front. Siona dependency group, which is a different story. Okay, this is starting to Python package plus build system. So what else did we do? What else did we work on? Plotting utilities. Oh yeah. And omega conf plus hydra CLI. And strongly typed Python code. And I think this is it. So this is the message we want to convey, right? That we went from something like this to this. Okay, so then maybe we can, let's see, we can maybe split this into something like this, because we need this figure to be a bit wider. And we need a big ass arrow here. Okay, we need this vertically centered. Modernization and modernization. Okay, this looks pretty good, I gotta tell you. So now we need to fiddle with the colors a bit. All right, so we have this thing now, which has PyTorch dependency group. Which has a different Siona dependency group. What color shall we choose here? Okay, I've done worse figures in my life. So oh, and last but not least, YouTube series. So this is our little shout out. Well, actually, let's do it a super big shout out. How about we do have it wrap everything? So we center back. Not the worst I've done, not the worst work I've done. Okay. Okay, need a bit more vertical center here. Should look good. And we need a master shape here too. Legacy code plus and paper. Previous paper. And we want this to go center back. We also need some vertical centering here. Modernize. Reproduce. Not quite. All right, so now what we need is, what I think I messed up is that I should have, can I just nuke the fonts? Not really. Let's see how this looks like if I export it. So I do export image. What do I need to do here? Yes, this looks okay. I'm missing a bit of vertical centering, it seems. Okay, so this is a nice hint that I should go a bit higher. Okay. Pretty good. Only selected, yes. Sure. Scale 3x. SVG. Interesting. Let's see what happens if I do SVG. Teaser. Is it saved? I guess. Upload. It is. Okay, so can I call it teaser? Figures teaser, let's see. Come on, work. Oh, what? Recompile from scratch. Well, the teaser doesn't, the SVG doesn't work. I'm just gonna do PNG then. Teaser, which is kind of a shame. It's kind of a shame. Teaser, PNG. Okay, it is large. Let's see. 3.6 megabytes. Wow, okay, so it is high resolution. Teaser, PNG. I hope this works. It does. Okay, looking pretty good, right? Wow. yeah, I think this is it. We'll go with this for now. So we have all the 3 papers that I want. Okay, there's only 4 pages in the paper, so we basically took like 3/4 of a page with figures, which is good because we're gonna need. Let me delete some of these tables here. Actually, let me comment this, I guess. Use table. I don't think we need tables, although they may prove useful. Okay. Math equations, a bunch of shit. Let me see how this looks like in PDF. Okay, it looks better when I download PDF. I wish we could have done this so it's nicely rendered, but it's okay for now. Width, text width, all right. Yeah. All right. This is it. So we gotta write the paper. There's no more dancing around it now. We have 3 figures. We're gonna have to live with the results. We gotta write the paper in like 4 hours. That seems doable. All right, so we'll do that next time. Thanks for watching. Or oh, actually you can't see here, but here we go. So paper looks good. Okay, I'm gonna have to move myself next time, but next episode we're writing, and that's it. Thanks for watching. Thanks for subbing, following, sticking around. See you next time. All right, we're back. We're back with DiSco-MIMO. The final thing left to do is to write the paper. Okay, so let's see how long that takes. Let's jump into it. Last time we did the figures. Let's start blasting the writing then. Okay. So let me clean up this template a bit. Title TBD, author TBD. I guess I can anonymize myself. Anonymous. At anonymous. We don't need affiliation because it's all anonymous. We don't need this. The conference is ACM Rep 26. 2026. I guess we can put this. Well, can I just comment these? Do I need these? I do not need these. Probably. Well, I don't know how to make them go away. Okay, well, this is not that important, I guess. We'll figure this out later. So let's see, what else do we start here? So we have a teaser figure. Let's write a caption for the figure then, right? The left side. Left. The existing code repository. For training and running sampling using diffusion models is a collection of loose Python scripts dependencies, entire external repositories copied, a hard copy of the entire external repository at loose MATLAB scripts loose dependencies Windows MATLAB scripts loose depends. Okay, so I need to cite. So let's cite Yangsong repo then, because it's NCSN v2. NCSN v2. Okay. So how do I cite the repo? The first thing. Oh, here it's online, right? So at online, NCSN v2 repo, okay, comma. Author is Yang Song. And Stefano Armon. Year is 2020. Title is Improved Techniques for Training Score-Based Generative Models. The URL is this one. Last accessed is March 2026. Okay, so then we can cite the NCSN v2 repo. We can start deleting some. We'll delete them later, all right? So it's a loose collection of NCSN v2 repo. MATLAB script looks dependencies and hard-coded paths and configuration values. Okay. Right. In this paper, we present our experience and results with a complete modernization, refactoring, and partial reproduction of the repository. In addition to all the modern Python packaging and user and developer experience improvements, the entire process of modernization was recorded and will be uploaded as a multi-episode YouTube series on our channel. There we go. So we got the teaser. This is kind of the abstract, well, it's sort of a teaser figure. Very good. Oh, perfect. We split nice on the end of the line. So this is good enough for now. Okay, so we got the reviewers hooked on it. Oh, what the heck is this? Oh shit, it wants description. Yes, it wants a description. I guess I gotta copy this too. Yes. Okay, all right, so we did it. Abstract we'll leave for now. Now let me write the captions for the other two figures. Okay, because this is how I like to start writing. So we have this, and let's write the captions for the other two figures. Where the heck are they? Okay, I'm gonna have to delete all this stuff. Yeah, we need to start deleting some. Delete, there we go. We have the figures. We don't need a section anymore. Equations we do need. We'll keep an equation here. We don't need, we'll keep a table example. I don't know what the heck this is. Title information, template parameters, we don't care. Template styles, we don't care. Template overview, we don't care. Introduction. Okay, we cleaned up the template for good. Let's see. Now it's gonna, can also delete a lot of these bib files. Yeah, we don't need all this stuff. Okay, all right, let's get back to writing now. So now we can write the captions. I don't know what this is, the figure. Okay, so the CDF plot. So what do we want to comment here on the CDF plot? Well, cumulative distribution function, CDF plots for 5 different data sets. Okay, the two dashed lines represent the original MATLAB generated data set, whereas this new the new Siona generated data set. The 3 continuous lines represent synthetically generated data with the original model as is, green curve, or the retrained model on the Siona generated data, but with 2 different sets of sampling parameters. One corresponding to the exact description in. We're gonna have to cite ourselves, okay? And one corresponding. Oh no, this is Yang Song to the original code. Okay, so we're gonna have to cite this paper now. And yes, I can delete all this stuff. I don't even know what this is. Okay, I'm just gonna delete all the, damn it, so NCSN v2, okay. So then I do shift and, or just page down, boom, okay. And we have Yang Song improved, and then I go, page up, page up, page up. I do not need all this stuff. Okay. Now we only have 2 things in our bibliography, and I can cite song improved. Okay. Actually, the order of these figures should be reversed, right? Because first we're going to talk about training. And actually, this is how I like to... Okay, good. So now let's talk a bit about... Oh, shit. I have to copy this stupid description. Okay. All right, we're kind of getting there. I mean, we basically wrote a page already, if you count all the limits, so we're gonna write more. Damn, we're gonna run out of space like ASAP. 4 pages is... That's not a bad thing though, I'm not complaining. We're just gonna have to be super brief. Come on, I can do this, let's go. Gotta hype myself up. All right, so now let's write the caption for the training figure. This is more important. So, training loss as a function of the number of training steps for the original blue curve, blue, and retrained orange model in the completely rewritten framework. The curve also, the 2 models are also, the 2 models are trained on different data because of the differences between MATLAB and Siona, but exhibit... Well, let's leave that comment for the text, okay? So let's just... the figure caption should refrain from making comments. Ode to the differences, to the significant between MATLAB and Siona generated training data. Score model training loss, denoising, score matching as a function of the original. The model architectures and training parameters are otherwise nearly identical. We can assert stronger, identical. Okay. An exponential moving average with a decay coefficient of 0.99 is applied to obtain smoother curves. Okay, I think this is good. This is enough. So let's start. Section. Modernizing. Reproducing. Comparison. Well, reproducibility. modernization. We'll keep these separate, okay? So first let's talk about the reproducibility section because it's the most sensitive one. Because we're not able to get nowhere near identical results, right? Like because the training data, right? Despite we generally find that reproducibility takes a hit in favor of modernization, but the core principles behind score-based generative models still allow us to confirm that we trained a good model. Okay, so this is how we want to make an opening statement here, because we have to take a hit. Find that reproducibility takes a hit in favor of significant modernization, but the core principles still allow us to confirm that we trained a good model that produces high quality synthetic data. However, a fundamental measurement that is independent of sampling is okay, to validate that the model architectures are exactly identical, we also successfully cross-loaded model weights between code bases. Okay, so once the model was trained in the modernized code base, we simply export its weights as a PT file, its model state, its state, all weights as a PT file, which is then loaded using strict mode in the legacy code base. The usage of strict validates that the architectures are identical. So we're repeating ourselves here. To validate that the molecules are exactly identical, to validate the model architecture, we successfully cross-loaded model weights between code bases. Once the model was trained, the modernized code base. Oh shit, how do I spell code base? How to type code base. Is code base a single word? Okay, the single, oh my god, okay. Code base as well. Apparently Overleaf has no idea about this. In the modernized code base, we simply export, once the model was trained, we exported its state all weight tensors as a PT file, guaranteed to be backwards compatible in PyTorch 2.x, which is then loaded using strict mode in legacy. The user strict validates that the architecture is successful. Usage of strict validates that the architectures are identical. To validate the NCSN v2 model architecture, so we're gonna cite song again. Oh my god, we're already at like 1.5 pages, dude. Like, this is wild. We're gonna run out of space soon. A fundamental measure that's independent of a fundamental quantitative measurement independent of sampling are the training loss dynamics. Figure ref fig train. Let's see how this looks like. Yeah, we're not gonna have room for tables. Like, what the heck? Oh my god, where is the... Why do I not have label? What? Yo, where's the label here? This goddamn template. Does it want it after? Yes, it does want it after. Okay, fine, fine. All right. Figure 2 plots. We trained the new model using exactly the same hyperparameters as the legacy code base, which include the same hyperparameters. The Atom optimizer with the learning rate of 10 to the minus 4. Epsilon is 001. Batch size 32. What else do we have there? And no exponential moving average of the weights. Note that this is an omission from the legacy code base, which deviates from the guidelines and All right, so figure 2. Let me break some new lines here so I can... Figure 2 plots the smooth training loss with an exponential coefficient of 0.99 for the 2 training runs. The loss curve for the legacy model is publicly available, was saved at the time together with the weights, and is still publicly available today. Definitely a plus for reproducibility. The difference between runs is expected because of the explained by the difference between the MATLAB and Siona data generation, MIMO channel data generation pipelines. Despite our best efforts, we were unable to well, we should let this for a clear plus and recommendation for reproducibility. The loss curve was saved at the time together with the weights and is still publicly available today. A clear plus, a positive recommendation for ensuring, for measuring a positive helper for measuring reproducibility. So we want to give ourselves credit because we are the ones that did that, put that there, so we'll take some credit. Despite the material difference between training data sets, we find that the models are somewhat cross-compatible when measuring the validation loss on each other's data. We obtain an average loss of, we're gonna have to measure this. Yeah, so we're gonna have to measure this. Oh, shit. Let me see. So we do val loss. for the legacy data evaluated with the new model. So we should do this. We need to go to the code for this. Okay, let me add a comment. Don't forget about this. Okay, so we'll have to see if we can populate this value. If not, we may have to give it away. So we have a subsection called training. We have another subsection sampling from trained models. Sampling synthetic data. So what do we want to, how do we want to comment? Okay, so we kind of commented this result. So there is a difference. We'll report on it. And we commented that the loss is good that it was there, so it allowed us to measure these. It is also apparent that neither model has fully converged yet, which means the original paper likely prescribes undertrained models. But for inverse problem applications, this may not necessarily be a negative. Aspect. Okay, we don't want to go too ham on the comments here. Let me just do a quick comment on sampling. Investigating the generally measuring similarity between a real and synthetic data set is a difficult problem. However, a distribution of wireless MIMO channels can be more succinctly and reasonably accurately quantified succinctly through the capacity through its post normalization through its capacity. This measures the amount of information a MIMO channel can convey when normalized in terms of its magnitude. Programmatically, assuming normalized channels, the capacity at SNR, at signal to noise, and our ratio of exactly 1 is defined as, okay, so let's just define the formula. C log 2 I plus H math RM det that's it. I'm gonna need a citation for wireless MIMO channel capacity. I think this is the big one. Limits of MIMO channels. Let's cite this one, bibtex. There we go. So we're citing Goldsmith. This is a scalar metric for each channel realization H, and we use the cumulative distribution function CDF across 300 across multiple samples to measure distributional similarity. Simply put, a better generative model should generate synthetic data with a capacity closer to the one of the training data set. Capacity CDF closer to the one of the training data set. This metric, capacity, also allows us to quantify the reproducibility gap between MATLAB and Siona, as shown by the dashed lines in figure CDF. Okay, so here's where we get our answer from, because there's nothing we can do here. Unfortunately, we got different capacities, so it's kind of over. Okay. I think this is going pretty good, to be honest. Yeah, we're actually writing at quite some speed. So let me take a break. This is a good stop for the episode, right? So this is kind of the process. It's not that big of a deal. We're not writing a fancy paper. We're just commenting on the results. The more interesting part will come though. I'm sort of getting through the boring stuff first, which is commenting these plots. What I'm more interested in is to write about the software experience, which is going to be the modernization software, right? So we'll have a section here. Modern Python packaging with UV, where we'll talk about UV for ourselves, cross-dependency groups. So basic UV, incompatible dependency groups, UV for external repos, for modularizing external repos, okay? UV for cross-platform enablement, Windows. Idiomatic Python modules, okay? So module and sub-module structure in SRC versus app plotting code. Modular CLIs, strict type checking in Python. Okay, so Omega Conf and Hydra based Pyrite and interaction with incompatible UV dependency groups. This is probably the most interesting thing that we learned. And here, okay, so this, I think this is it then. We just have to write an intro and an abstract and a conclusion and we are done, right? I don't understand why I have so many things here. I guess. There were undefined references. Ooh. Where? Oh, come on. Is it the stupid figure again? It's like, why is my figure dumb? Where the heck did figure 3 go? Excuse me? Please. Is it not like... Jesus Christ, I have to recompile from scratch? Oh man. Yo, where did the figure go? This is so confusing. CDF underscore plot PNG? Did I just not like see this? CDF plot? Well, anyways, I gotta keep writing. So section, conclusion. This is the outline. Still, where Where's the figure? Like if I cut this, oh my God. I can't. Is it not like right? CDF flaw. Let me delete this SVG, I guess. I don't know what the heck is happening here. All right, well, the template is obviously broken because we just saw that figure many times. And it decided to like just vanish. And now I'm really pissed off. Like, what is going on with the template? Is it something I typed here, for the love of God? Like, if I comment this? Is it this stupid new page? It is the new page. Dude, what is up with the new page? Alright, we're not playing the new page. Holy. So can I put this back? No, I can't put... Wow. Wild. Yeah, the template is just broken. Like, should I just move this higher then? I don't mind. Interesting. It's just like, should I do HT? Nope, it just decides to die. Which is like... words, TB conclusion. Alright, well, I'm gonna have to, I have no idea. I'm gonna have to keep writing and hopefully this figure appears because I don't know what the heck am I supposed to do with it. It's wild to me that this other one works. I don't know, maybe I should... Nah, it's not that. Like, obviously the other one works. Is it like the citation in the figure that's acting it through? Previous work. Yeah, it's not that, obviously. Yeah, well, this is fried. Like, I have no idea how to fix this. Should I just copy more text? Like, if I copy more text, does it magically appear at some point, one would hope? Copy, 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 copy. Let's see. Maybe it doesn't have room to float. Yeah, it doesn't have room to float. Okay, well, the template is still broken. Like, it should not act like this, but sure. All right. Okay, so this is a good time for a break. Thanks for watching. Thanks for sticking around. So writing's going pretty good. We have like 2 and something pages. So we're getting close to the 4. 2 more, 3 more hours. That should be it. We'll be back next episode. Thanks for watching. And we'll be back after a break on stream too. All right, welcome back. We're back, one of the final episodes of DiSco-MIMO, probably 1 or 2, 3, 4, not too many left because we wrote half of the paper, so we're in the writing stage. Thanks for watching on YouTube, thanks for following. Don't forget to sub on YouTube, follow on Twitch, you know it. Let's get back to writing, straight to writing, okay? So let's finish writing about sampling because we did find some differences here. Okay, remember what I want to write about is that the parameters were messed up in the original code and we had to meddle with the initialization too and the beta coefficient. So capacity allows us to quantify reproducibility gap between MATLAB shown by dashed lines. It becomes clear, it's clear that the two distributions are significantly different. Sorry, and despite our best efforts, we were unable to reconcile the Siona simulator with the MATLAB behavior, mostly given that MATLAB itself, because of a lack of MATLAB access. Moving forward, we heavily favor Siona because of its open license, because of its permissive open source license and native Python packaging. Okay, so we're gonna diss MATLAB here a bit. It's clear to despite our best efforts, we were unable to reconcile lesson learned. Maybe we should do some lesson learned type of things in LaTeX. We favor Siona for scientific MIMO channel research because of its due to its permissive open. Okay. Figure, once we accepted the training distribution gap, moving past the training distribution gap, the training data distribution gap, figure 2 reveals other interesting reproducibility aspects in this particular application. Let's just comment them as items, right? So begin, oh my god, itemize, oh my god, come on. Okay, item 1, item 2, item 3. Score-based generative model sampling is highly sensitive to hyperparameters. And there is a dual mode behavior we uncovered when inspecting the legacy code base and comparing it to the paper. they each report a different set of sampling hyperparameters. Okay, this sentence is getting too long though. Let's pull it into a... This experiment shows that score-based generative model sampling is highly sensitive to numerical hyperparameters, and there's a dual mode behavior. The legacy code base uses two hyperparameter values of, I guess we'll have to just name them here. Alpha is 3 times 10 to the minus 11, and beta is 001. While the paper recommends following the automated procedure in song. Despite this, when implementing this procedure is not implemented in the code base, in the legacy code, and following it yields hyperparameters of alpha approximately what was it, 125 times 10 to the minus 8, beta 1. Despite the 3 orders of magnitude difference in alpha, we find that both sets of hyperparameters produce synthetic data of reasonable quality. Holy shit, the writing is, we're writing so much now. I'm worried we're running out of space. Okay. Figure, fig CDF plot. Summarizes this through the 3 solid line plots. Through the 2 solid line plots from the reproduced setting. Following the paper yields a distribution very close to that of the Siona of the training data in the modernized code base, while following the legacy code base settings, produces a slightly different data distribution. This is validated in the legacy code base itself by regenerating synthetic data, green curve in figure, and noticing that it also deviates from its own training distribution. To conclude, we implemented a clear, our modernized CLI now takes all these parameters, including an auto option for determining them according to, takes all these values as optional inputs, allowing researchers to systematically experiment across them. Okay. Regardless, our modelized CLI code base, CLI equipped code base, okay, I think we're done commenting on the results. Like, this is as much as we can do for 4 pages, right? So we noticed a bunch of differences. We'll review the writing later. Now, let me talk about I'd like to, oh shit, no, wait. Reveals other interesting results in a particular application. Well, this is enough. Another interesting usability aspect of this particular application. We found that and exhibits probably have room to write more here. Interesting. Report a set of the legacy code busy hyperparameters values. Okay. All right. So we should let's see. Let's not space too much here. For the 2 training sorry, we use 10,000 samples, the entirety of 10,000 samples to estimate the CDF. Whereas for synthetic data, we generate 300 samples with each method, given the sampling costs. Given sampling requires us to run a Step deep neural network inference. Okay. All right, so let's see what we have here. Okay, so I think we're done with this section. Oh, sorry, my throat is on its way out. What we need to do now let's write about the modernization that we did. I don't think we're gonna have room for tables, so we can ditch these. Maybe we'll see. Our primary goal is to modernize the code base and make it significantly more accessible to researchers. We identify and we identified the following high-level desiderata, okay? So what did we want to do? And tackled. Well, first, we need to get rid of MATLAB dependency and move to a full Python solution. Given that MATLAB has no official Python bindings and its expensive licensing costs, we strongly favor. Well, let's see. Does MATLAB have Python bindings? I gotta be careful what I say here because I don't want to get myself banned. MATLAB Python. It does have MATLAB engine API code computation engine from Python. Hang on, I gotta get some water. So maybe we say about dependency. We want a cross-platform lock file centered based approach for dependency management. Dependencies should be fully resolved and have exactly specified versions. Okay, so what are Python log files? UV log files. Let me quote UV then. Okay, so I can do a footnote and I can do URL this. Let's see how this looks. sync and lock file based approach, dependencies should be fully resolved and have exactly specified versions, ideally across all platforms: Linux, Windows, or Mac. So we want this. Saying we need to get rid of MATLAB is it's not a desiderata, it's a consequence of this. Now, what else did we want? A CLI. A research friendly command line interface for the main applications a researcher would run. Training and sampling from a score-based generative model. We want the CLI to encode sufficiently many hyperparameters such that users make 0 changes to the code in the initial exploration phase. Okay, so 0 changes to code. So we need a CLI. A key component for answering the first desiderate. What? Desideratum. Jesus Christ. For the first desideratum, is a Python dependency management software. We choose UV. All right, so let's cite UV. How would you even cite UV? I guess we'll do them a favor, we'll cite them. Okay, so it's Astral. Well, they got bought by OpenAI, sure. So I guess we'll put them here. 2026 title. UV. I'm extremely fast. Python is written in Rust. Okay, so we can cite UV. We chose UV due to its powerful feature set and cross-platform compatibility. A first major advantage is that UV manages Python installations by itself across platform which relieves the burden, which relieves users of having to track multiple Python versions, multiple track and refer to multiple Python installed, multiple Python versions installed on the same machine. Subsection, modular. The first work item was to refactor the code from loose.py scripts at the root of a repository into a to a proper Python module. Project structure. Actually, I can, let's see. I can do a subsection, right? This is easy. This is easily done by running uv init Python version which produces okay, so we moved everything to src-mimo. Oh my god, I'm already at page 3. Holy. Alright, gotta take a quick break. We'll be back. So we have to write more about this. We have to write more structured. All right, we're back. Actually, I realized we may need some Tomo code listing. So let me see. Overleaf Tomo code listing. Okay. So let's see. Can I do this listing? Maybe this works. Okay. And I need use package listings. Oh shit. Minted. And what does it want? Does this work? Maybe. I don't have free account. Yeah, I can't do this. Oh, come on. So now it won't let me even compile this? Oh, shit. Damn it. I need to ask Gemini because this is wrong. Damn it. How to highlight Tomo in latex listing. It's not a standard language. I need something clean, minimal that works with free overleaf. Fast compilation. I can't do like weird shit, dude. Yeah, so we can define our own language. Although I'm worried this will slow. Oh my god. Okay, I don't even know what the heck this is. So can I do Tomo now? Kind of. Yes, I can do Tomo. Oh, interesting. Okay. Oh, what? Font shape. I mean, yeah, there's some weird shit here, Jesus Christ. Okay, I guess we'll take this. All right, so This is augmented by running UV init. Which moves all project packaging and dependency management to a by project toml file with the basic skeleton, with the basic configuration shown in listing ref whatever label lst toml basic. Yes. Let's see how this looks. Let's okay, so it's not too bad. Okay, I've seen worse things in my life to put in a paper. So now let's just copy from our code. So what's the basic project? We can cut some of this stuff here, right? Name MIMO. Score based MIMO transformation. Requires Python. Okay. Build system. Build system is very basic. A basic pipe project. Basic pipe project toml file already makes already is sufficient to make this to turn a repository into a proper Python package that is installable directly from a GitHub repository. Let's see how this looks like. Note that using UV allows us to immediately upgrade Python from 3.9 to 3.12 limitations. Limited by the Siona package without having to install it on our explicitly install it on our machine. Packaging external dependencies. Another glaring issue with the legacy code base is that it heavily depends upon the repository in NCSN v2 repo. Unfortunately, because this repository is not properly set up to be properly packaged, it is not installable and must either be sub-moduled or hard copied, which is what the legacy, the latter of which is adopted a Git sub-module or hard copy, the latter of which is adopted in the legacy code base. Possible licensing issues aside, this significantly bloats the code base with 30 plus files, out of which only 5 are truly necessary. The deep neural network and describe and contain the deep neural network architecture. The solution is identical. Solving this is easy. We easily solve this by forking the repository and once again applying the principles in the subsection we just talked about. Label subsec UV package hours in section ref subsec, applying the method in to properly package this repository. Once this is done, in our main repo, we can also use UV's Git dependency feature to specify it as a Git sourced dependency with a specific commit ID, thus locking it down to an exact version in time, as shown in listing the next one. In our refactored repository, once this is done, we can also use for our refactored repository, thus locking it down to an exact version in time without copying any files, as shown in listing. Because we also significantly delete files from our fork, the remainder of the code just depends on Torch and poses no depends only on Torch. And poses no difficulties to UV's dependency solver. Okay. So we're done with packaging external dependencies. We're done with loose scripts. We're done with external MATLAB. Oh my god. Okay, we really need to. The biggest remaining challenge: dependency, mutually exclusive dependency groups. Adding a research friendly CLI Python type checking for clean code. All right, we have about one more page of budget and we need to talk about the application too, and that's it. It's looking pretty good. Gotta tell you, it's looking pretty good. We'll specify this. Tuk. Yeah, this can be promoted to a subsection actually. Mutually exclusive dependency groups is one of the bigger challenges. The biggest remaining challenge is bringing all dependencies into Python world. Given that the legacy repository depends on MATLAB. We use the Siona library we instead switch MIMO channel data generation and simulations to the Siona library. Let me see, Siona. Oh my god, I forgot to, sorry, I wasn't sharing the thing. Sorry, I was writing this paper all this time. I was stuck on VS Code. Thanks for sticking around or joining. So we're writing this research paper. We're at 3 pages out of 4. We're kind of running out of space. All right, so let me, I have to cite Siona, NVIDIA, which is interesting. Do they have a citation? Yes, they do have a citation. Good. So, very good of them to have a citation. Oh god, but this is like ancient, dude, like version 2. Oh my god, I don't even have version 2. No way, they just migrated this to PyTorch. this undermines all the work I did. Hilarious. I guess we'll reference the old version. There's nothing else I can do. This is actually hilarious. Okay, so we have to write the paper about Jesus Christ, dude. We have to write the paper about version 1.2.1 because I'm gonna go insane. This is so funny. Damn it. Siona library. A native Python library. However, this brings another dependency challenge. As of the time of writing Siona 1.2.1, the latest Siona version that we considered when starting this work was TensorFlow based, and its dependencies were incompatible with PyTorch, specifically because of NumPy 1.x versus 2.x issues, backwards compatibility issues. Fortunately, UV comes to the rescue once again. Once has a feature made exactly for this case in the form of exclusive dependence of incompatible dependency groups. We should cite these. Let's see, dependency groups. So incompatible, what is it called? Exclusive. Where the heck do I see this? Where did I find those things though? Oh, come on, man. UV exclusive dependency groups. What feature did I use? Oh, it's conflicting. Conflict? Yes, declare them as conflicting. Here it is, conflicting dependencies. All right, so we need to cite this form of conflicting dependencies, right? Dependency groups. And then I can do a footnote, URL this. We use this feature to allow Siona and PyTorch the Siona code needed to generate training data and the score-based generative model training and sampling code to coexist using two separate dependency groups as shown in listing. Okay, the user, the researcher experience is very friendly and consists of the following pipeline to completely to train and test a score-based generative model from scratch. Of the pipeline, the researcher experience, I should add this here. All right, so I gotta write two of these listings now. Oh my God, we're getting close to page limit too. Okay, I can't believe they solved that problem though. This is the dumbest thing ever. So basically Siona, okay, let's not talk about that. All right. Oh my God, what is this? Illegal parameter number, footnote URL. What the heck is this? Can I not escape this? I can, okay. Design. Solve this by forking the repository. Okay, I gotta write some code examples and I'm on the 4th page already. All right, let's not panic. So we're right. Okay, so listing. So we need a code listing here that shows, what do we say we're gonna do here? We can call this B. It's still toml. Oh yeah, toml git dep. We just want to show people what we did with our and Py project toml section in listing. Okay. Yeah, ref lst toml git dep. Okay. This looks good. Okay, so what do we want to show users? I mean readers. I just need this little thing. So I'm gonna do it this way. Dependencies is and it'll depend on NCSN v2, okay, and then we have to show, so this is in the project section, okay, And we need to show how to link it. Yeah, here it is, tool UV sources. So we just want to show the source, okay, which is path to forked and rev commit ID. Anonymized. Okay, so that's it. So if I just tell it to look here for NCSN v2, then pip install just works. Nice. So we're done with one more example. The required section amendment, the required amendments to pip install to make any, to use any properly packaged Python repository as an installable dependency in our project. The amendments required in this case the fork of the NCSN v2 repository. All right. And should I put a dot here? I think I should put a dot, right? Yes. Oh, what happened here? Whoa, 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 whoa. Damn it, I need to escape this. All right, so we have two code listings. And it has a revision. Okay, on to the next one. Sweet Mother of Mercy. On to the next one. Damn, we really need to add more references. Can I find the citation for NumPy? Oh shit, I forgot this again. Man, I'm really doing a bad job with this. Can I find the citation for NumPy 2.x backwards compatibility? Because I know it's really broken. Yeah, it is. Okay, I'm just gonna cite this here. So I'm gonna cite it as a footnote. URL. Psht. All right. Okay. Next, where were we? Oh my god, I still need to find that value. Yeah, we're not gonna have time for tables for sure. We still need to write the intro, but we're almost done with the modernization. Okay, more. Mutually exclusive dependency groups shown in listing. Okay, we're gonna need an example of the dependency groups. Something minimal here. So toml dep groups. Okay, so ref lst. Oh shit. Why? LST toml dep groups. Okay. Two separate two dependency groups. Now, what do we need to show users here? Here, we need to show them the conflicts, Sayona no RT, and torch. We'll just show them something bit lighter here. So torch, NCSN v2. Yeah, this is enough. Sayona and conflicts. There we go. Sayona we can crunch on one line. This also allows us to immediately update PyTorch from version 2.3 in the legacy code base up to 2.10, enjoying an approximate delivering and immediately to update delivering delivering, I believe it's about 8% training and inference speed up for free. Okay, this is it. So we just need a caption for this now. All right, I can kind of crunch this down a bit. Let me see. Yeah, I'll have to crunch the lines here a bit. Okay, all right, so we have our listings. Amendments. Defining two conflicting dependency groups using UV. We use OmegaConf and Hydra All right, so I have to cite omega conf now, which may not be that easy because these things, they may not have citations. Okay, we're almost done. We gotta take a break. Oh my god, how do I cite omega conf, dude? Seriously? I gotta make... So omega conf, is there a title for omega conf? I'll just call it a hierarchical configuration system. Okay, so this is omega conf. And Hydra core. A framework for elegantly whatever. Okay. And I'll just put it here. Okay. All right. So omega conf and Hydra to add a fully featured CLI to our 3 user-facing applications. Data generation using Siona, score-based generative model training, and inference. The resulting in particular, we use omega structured configurations which live directly in the Python module files and not in separate .yaml files to improve developer experience by having the configs as close as possible to the code that utilizes them. Okay? The resulting researcher experience, developer experience, rendering consists of a pipeline of a click to run pipeline to train and test the score base to generate training data, train, and test the score-based generative model from scratch, as shown by the 3 sequential commands, one for each part of the pipeline in listing. Okay. All right, this looks pretty good. We're approaching the page limit, but we still have some room left to write, so we'll keep writing. Thanks for watching so far. Thanks for follows, subs. This is a good stopping point. We'll keep writing next episode or after a break on stream. Thanks for watching. Stick around. All right, we're back with more writing. We're at 3 pages and 25% of the 4th page. Oh no, like 30. Nah, 25% because references don't count. So we're getting there, 4 pages, and let's keep writing. Push, push, push for the writing because the deadline's coming close. Thanks for watching, or thanks for stopping by. Thanks for watching on YouTube. Don't forget to follow, sub, you know the drill. All right, so we were left at adding a research-friendly CLI where we talked about Omega Conf, Hydra, to add a fully featured CLI for 3 user-facing applications, data generation, blah, blah, blah. The resulting developer experience, the final developer is research-friendly and consists of a click-to-run pipeline. Okay. as shown by the 3 sequential commands. Okay, so we want to show some bash thing. Oh my god, please tell me this listing thing has bash. I'm gonna have to ask Gemini. Can you give me a bash language tool, or does it have it? Or can we just use plain something? Oh, come on. We're not doing my bash. I can't afford my bash. I can't afford it. Let's use plain. I don't want to argue. Yes, exactly, Gemini. Okay, so let's see if bash works. What the heck? Did I not copy? Come on. All right, so language bash caption is stuff. What is it called? Label lst bash devx. Okay, so now I can say enlisting lst bash devx. Boom. So what are the commands I actually run? Well, they're very simple. Generate data and write it to files. Notably, we also parameterize all file input, output to fully specified paths augmented by robust post-init verification in each app. If an input file does not exist, an error, a verbose error, is raised to the researcher. Compared, this is miles ahead. Nah, I don't want to use. Okay, so what is UV run group Siona -m MIMO.cdl save file path to data.h5. Okay. File. Train on generated. Train on CDL channel data. Group torch -m MIMO.train data file path to data save model dir and save model to risks. Save dir path to model. Okay. Generate synthetic data using a pre-trained model. Oh my god, am I doing the right thing here? Let's see how this looks. How does it look? Oh my god, it looks really bad. I guess I have to do this thingy here where I... I don't like default bash because it comments are italic and fonts too large. Anything clean and more compact can be another language too. There's no way we're using this. You're insane. Wait, using language SH is cleaner. Let's try this. Does this look cleaner? My ass looks cleaner. Jesus Christ, this looks so ugly. Come on. I'm not putting this in the paper. Comments are now upright and clean. Do I have to put this though? I'm gonna use this, but if it nukes the compile, I'm in big trouble though. Baramono. Oh, okay, I do like this. Oh my god, it does look nice. It does look nice. Break lines true. Can I not have this shit though? Yes. Okay, this looks... Okay, it looks more human for sure. All right. So where was I? Generate data artifact DiSco-MIMO train. I need these parameters now. Space. I guess we'll do it this way. Yeah, we'll do it this way. So now how do I MIMO sample model dir path to model path to results. Okay. To the developer with fixed instructions. Okay, we have an example of bash. Wow. We only have half a page left. Okay, finally, we make full use of Python's optional but strongly recommended static type checking system. By adding formatting and by adding pre-commit hooks for automatic formatting and type hinting and type checking. This forces developers to annotate, to type annotate every, including ourselves, every Python functionality and implement robust runtime checks whenever needed to guard against invalid values. We use rough for automatic formatting and based pyrite, a fork why do I use based? For extensive type checking. An interesting challenge we had to overcome was combining pre-commit hooks with UV's mutually exclusive dependency groups, because only a single state of the virtual Python environment exists on disk at a given time. We resorted to using local pre-commit hooks that each run under UV run group name to properly type check Siona and PyTorch. The Siona and PyTorch parts of the code base. All right, so we have to start we gotta find a title for the paper too. Oh my god, I can't believe we're getting so close. It's actually happening. Yeah, there's code in here, there's dependency groups. Why does text TT look so ugly now? Holy. Ay, 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 ay. This is fine, I like it. But it seems to also affect all instances of text TT. Can I actually have it not do that? Oh my god. Because we use fonts in the picture, it starts bleeding into your leg, it may like the rest of the document. Ay, 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 ay. Replace your previous LST set. Set default as. So I put style. Jesus Christ, man. Like, am I supposed to use the Baramono thing? I'm gonna run out of compilations. No, I did not run out of compilation time. But I still mess with... Dude, are you messing with me? Wait, maybe he wants me to use... But why am I messing with the TT? Oh, no, I didn't. Oh my god, it worked. This is what I want. Okay, can I like not skip above and caption? Like, what is this shit? I don't want to skip above the caption. Oh, come on, man. Okay, this is kind of good. Okay, I kind of like it. Let me see how this reads. Oh, sorry, I was reading this. Okay, we're getting there. I like how it looks. Now, we gotta write the caption for this stuff thing. The complete sequence of commands to run the full research pipeline from scratch. Sequence of bash commands. No, the sequence of multi-platform commands. This works on any platform that runs the full research pipeline in a deterministic seeded way. Finally, we also add seeding to all modules. Random seeding. All right. Oh shit, I have to cite rough now. Oh my god. Okay, come on, rough. rough. How do I cite rough? I just do this thing here. So rough Astral Inc. Good one, because they got bought by OpenAI. All right, rough. What is it called? Extremely fast, blah, 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 written in Rust. Very good. Linter and code formatter written in Rust. Okay. And the other one we have to cite is based pyrite, I guess. Okay. So we go based pyrite X. I don't know, we'll call it based pyrite. And we shall call it I'll call it this, a fork of pyrite. Pylance features and more. All right. Oh shit. So now we have to go into main and cite rough and based pyrite. Okay. Can I escape these UV run group? Does it work like that? I believe it does. No, it does not. Like, I can't type double dash? Okay, so I can't do this? Dude, this is wild. Oh my god. How do I type a double dash inside text TT? Helpfully converts to hyphens. Why, I have to put it in curlies. Minus. Okay, thank you. All right, dash dash. Chuk chuk chuk. Chuk 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 chuk. Is this also converted? No, this should not be, right? Because it's a yeah, these are fine. Okay, well, I think this is it. We don't have any more room in the paper. We wrote the full paper to validate the NCS model architecture, blah, blah, blah. Let's cite ourselves. We gotta cite ourselves because we say, well, let's write the intro. Okay. Where the heck is the intro? Here it is. Legacy research code is often a significant pain point. Despite certain pain reproducibility with many popular repositories from the 2017, 22, 21 period still being used today, despite still used as they are today, despite their tooling being out of date. This is even more true for Python, where dependency management was hell was a well known issue at the time. Despite these short... So can we find the citation for this? So let me check. Oh my god, if I can find some sort of news that says Python dependency hell. There's a shit ton of work. Oh my god. This is hilarious. This is hilarious. Like, this is actually a problem. Wowee. I'm so happy I found this now. All right, so dependency hell being a well-acknowledged issue at the time. It was a well-acknowledged and studied issue at the time. So we gotta cite this guy and more. Oh my god. This is hilarious. Another one. Give me one more. Yeah, there's like smart pip, all this shit. Like, this is wild. I'm so happy I found this now. Smart pip. Okay, I'm going crazy. All right, so this is even more. This is even true. This is clear. This is definitely the case. This is the case for Python, where dependency was well acknowledged at the time. Fortunately, ever since, modern frameworks like UV have largely solved these issues. Our goal in this short paper is to present our systematic approach to modernizing such a repository. In particular, we target the repository at site, hours, anon. I'm gonna have to anonymize ours. And its associated publication. I'm gonna call ourselves high impact. It's just publication. Okay. Cite, our, paper, anon. Okay. So I have to cite ourselves now. So score. We have to cite ourselves. So first, let's cite ourselves. Boom. Okay. Now we have to be careful. We need to anonymize this because we're gonna get disk rejected. Okay, so we'll put ourselves. How do I comment this? What? I have to manually. Oh, okay, here we go. All right, so anonymous. 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 Yeah, let's anonymize ourselves. There we go. So this becomes our paper anon. Well, it can be our paper. We don't need this thing because we can just swap it then, right? So, boom. This is the repository is an application of score-based generative models in wireless multi-input, multiple input, multiple output, MIMO channel estimation. We picked this particular application area and repository because the source code, because it covers 3 aspects that are still very relevant today. And they are generating scientific training data using scientific software, scientific simulation, non-deep learning software, training a score-based diffusion generative model, generating synthetic data using a pre-trained score-based generative model in high precision domains where hyperparameters are sensitive. In scientific domains are sensitive to numerical variations. I gotta cite our repo too. So for that, we shall do this. Anonymous. So anonymous URL anonymous. Why do I have errors? Oh, for God's sake, man. I can't use the article. Hey, thanks for stopping by. I'm wrapping up writing a paper, which I'm going to submit to a conference. That's pretty much what's happening because I worked on code. And I got to write a 4-page paper. It's actually pretty interesting because the paper is about what I streamed for the last month, which is if you look at my YouTube channel, there's a giant ass series about reproducing one of the papers from my PhD with generative models and all that stuff. So I went through all of that, dealt with a lot of issues, and now I found this reproducibility conference, and I basically spent today writing about that experience in about 4 pages. And that's where we are right now. So let's see, where was I? Oh my God, why is the citation busted? Oh, repeated entry, article or paper. Oh, this is easy to fix then. Is it? Very confusing. So we're our paper. It's only one. Yeah, check out my YouTube channel if you feel like it, but if not, it's fine. I wouldn't worry about it. Just messing around, finishing this paper. What the heck? There's 23 errors. Oh, I guess the citation is broken now. Missing number treated as 0. So what does it want from me here? Does it need like a year? Well, I'm just gonna put anonymous too. Okay, we're past that. No more stupid errors. So we're just gonna anonymize ourselves for the submission because we can't reference. Okay. Come on, where was I? Fortunately, ever since, modern frameworks like UV have largely solved these issues and enabled much more seamless dependency management. Non-deep learning software, training a score-based diffusion generative model. It's fine, I wouldn't worry about it. It's like... just feel free to ask anything, but I gotta finish writing this. If you read this paper, it's not that bad. Because I didn't really learn anything new from the series. We just struggled to sort of reproduce the work I did 4 years ago, which was pretty bad, to be honest. Like, it took a lot of time. All right, so I gotta finish the conclusion. So what the heck did we do here? Ah, shit, and I have to find this. Let's put this 120. I'll guesstimate it. Check later. Why do I still have so many? Okay, this is fine. So I need to drag this to a new page. So I only have 4 pages for this paper. And I'm actually running out of space. Okay. This is all the space we have. Okay, which is a lot actually. I have enough space now. So, write the conclusion. What the heck did we do? Let me think here. We have room for some little math here. Nah, hang on. So what is the conclusion? So I gotta write about the YouTube series in the paper too, which is also pretty hilarious to write about. Modernizing the legacy code base took approximately 40 hours and was all recorded planned and will be released as a multi-episode YouTube series. Okay, the most difficult part was reproducing the sampling algorithm because of its high sensitivity to numerical parameters and the misdirection in the original code base, which deviated from the associated paper. Okay, because we had a lot of trouble with this shit. I wrote something in the paper, but then the code was not doing that. Okay, what else did we learn? Anything else interesting? Additionally, we were not able to overcome the fundamental gap between Siona and MATLAB simulations of the CDL channel family, despite matching as many parameters as possible and even trying some variations. To the best of our However, despite these differences, training a score-based generative model was successful. The synthetic data resembles the new training data closer. Oh yeah, it is a weird one, right? Try to guess. I don't know. I'm US based right now. I'm on the West Coast. Yeah, it is Eastern EU. Yeah, originally. Yeah, you're right. But I've been in the US for a while now, for almost 10 years. However, despite these differences, training a score-based model was all says synthetic data resembles the new training data closer than the original code base did. Future work should continue investigating other downstream applications of the retrained. Should continue. Future work could continue the modernization and reproducibility of other downstream applications of the retrained generative model. In particular, MIMO channel estimation using conditional sampling, as in the original paper. We're gonna have to cite us here. Despite these differences, training score was successful. No, it is Eastern Europe. No, you are right. I won't tell the exact country, but you are right. Okay, what the heck do I need to do here? So we're not able to overcome the fundamental gap. The numerical this is due to the legacy code base. This is because of no longer having access to a MATLAB license, which makes a case, which reinforces the case for an open source package like Siona. Man, this is kind of a strong claim to make. I'm gonna shit on MATLAB now. Despite these differences, training, Scorbit, and the modernization was very successful. Future work it is now also trivial to change another improvement that it was already done and not discussed in the paper was that we were easily able to add support for using neural network architectures from the popular diffusers library, finally breaking away from the NCSN v2 architecture. This enables future work to research better architectures and hyperparameters for downstream applications of score-based generative models, in particular MIMO channel estimation as in the original paper. All right, so we have to cite diffusers now. What the heck do I have to do here? I do have to cite diffusers. Ah, shit. And I have to write an abstract. Oh God, what is this? Diffusers library. State-of-the-art diffusion models for video. Is there a citation? There is a citation. Oh my God. Okay. What else do we need to do? Diffusers. I think this is, oh no, we have to write the abstract. All right, abstract, short summary. we present our systematic approach for modernizing and attempting to reproduce a legacy code base that trains and samples from a score-based generative model. In the field of wireless communications research. We rewrite the entire framework from scratch with modern Python packaging, dependency resolution, and a research-oriented command line interface, CLI. Despite we find the biggest challenge lies in non-deep learning scientific software reproducibility when trying to match a MATLAB wireless channel simulation library, when trying to replace with its Python open source counterpart. Holy shit, how much room do I have? Oh my god. It is not good. Oh my god. Ah, it's over. Okay, we can cut some of these little thingies here. Oh, I hate these though. Why do I need all these stupid templates? One, two, three, four. I gotta write one more thing in the abstract though, because I need to write about the entire process, including the writing of this manuscript was recorded and will be uploaded as a YouTube series. All right, now I have to make this fit in 4. But before that, how do I fix all this? I mean, this is easy, okay? I can just crunch some of these paragraphs here, I think. Our goal is to present a systematic approach documented systematic efforts to modernize the repository. Where did I put that stupid lesson learned? I gotta take that. Nah, I can cut this. It's too much. I can crunch these two together. Okay. Yes, I'm in 4 pages. Okay. All right. 4 pages. We need a title. Oh shit. What is the title of the paper? So what do I do with all this stuff? Like, can I just not cancel this and it doesn't show up? Like, please? Because I really want to save that line. So if I comment this, what happens? Like, what is even conference 7? Where's Washington show up? Okay, so I have to follow this guide here. God, I hate this template. So it says for managing, no, not citations. The abstract, where is that thing I added though? Oh, here it is. The code below is generated by the tool at CFM. Please copy and paste the code. Okay, what the heck is this tool? ACM computing classification. Dude, what is this? You haven't added any. The ACM was a polyhierarchy ontology and semantic web because it's a traditional version of this classification. Yeah, I don't know what to do with this. Like, this is fucking wild. Like, physical science. No, I don't want this though. Where the heck do I find reproducibility here? Telecommunications? Nah. I don't know, low relevance. Okay, so how do I cancel all this stuff now? Oh, I see, CCS. So where do I find reproducibility though? Computer systems organization, no. Networks, no. Software, it's software. Software maintenance tools. Configuration management and version control system, I guess. High. Software maintenance tools. Medium, high. Software creation, notations and its tools. Designing software. Post-development issues. Version control. High relevance. Maintaining software, high relevance. Okay, generate code. What the fuck is this, dude? Like, I take this and I copy it here. Oh my god, and it's gonna give me the... Yeah, but I don't want these in like... I don't understand. They put them in the wrong order though, because I... Okay, sure, whatever. I see, so it ate some space for me. So what do I do for keywords? Python, dependencies, generative. Tooling, score-based, generative models, wireless, CLI. Okay, what is this conference 17, July 2017? Where's that coming from? Is it because I put this? So if I de-cancel this, but where do I get this? Yeah, it is ACM rep. I don't know where ACM rep is. Where is it? Delft, Netherlands. Delft, Netherlands. It's not June, it's July 20, what is this, 18? No, 2022. $2026. Okay. I don't know, I'll delete this from your rights confirmation email. I don't know what that is. Okay, I broke the thing. I broke the thing. Oh, I see. I did not break the thing. Okay. So we only need a title now for the paper. Holy shit. Title. What title do I put for this paper thingy? Oh, yeah. So we can say modernizing a legacy code base, Python code base, using, that's it, modernizing the legacy Python. This is the most boring thing. Modernizing the legacy Python code base. God, I need a catchy title. Okay, we don't have this problem. Oh, this is the copyright thing? Well, hang on. What does this do? No, I don't know what that does. Doesn't do anything. Anonymous. Okay, yeah, this anonymizes. Doesn't do much though. Title: Modern Resident Legacy Python comments. I can't. If I put that title, I'll give away, and I'm giving away. I guess I'm just gonna put UV. Like seriously, I'm gonna put. Well, it should be. Damn, this is the most boring title ever. Alright, gotta take a break. I think this is it. I mean, we're kind of done though. I'm getting tired. Let me take a break. Let me see what title did I put in the... I wonder what title I put... let me check right now actually. What the heck kind of title did I put in when I registered the abstract? ACM. Rep. Oh shit, it's the other one. ACM rep. I called it even worse, reproducing and modernizing Python research code using robust... Oh god, I'm not reading all of that. Yeah, okay, I think I'm semi-happy with this. Well, I think this is it. Let's proofread this one last time. And this concludes... well, not all of it, but a large part of the DiSco-MIMO series. So, what do? We went from this legacy code and paper, who has a bunch of red things, which are not good. We modernized it. Did we reproduce it? Not really, but that's fine. To a very modular thing, right? So now we have a full Python package and a build system. We have 2 dependency groups with sub-modules. We have a Py project, we have pre-commit hooks, OmegaConf and Hydra CLI, strongly typed Python code, all this stuff. So the existing code repository for training and running sampling using Fusion is a collection of Python. Oh shit, it's not diffusion, it's score-based generative models, a collection of Python scripts, okay? All Represent 12. So 12 is a hard copy of the entire external repository. MATLAB creates loose dependencies. Loose dependence. What is loose dependency versions? Hard-coded paths and configuration values. Okay, right. We present our experience and results. We document. The result of our complete modernization re-implementation, refactoring, and partial reproduction of the repository. In addition to all the modern Python packaging and developer experience, to Python packaging and developer experience improvements, the entire process was recorded, featuring Python packaging and developer experience improvements. The entire process of recording will be uploaded as series on our channel. We can cut on our channel as a multi-episode YouTube series. Okay, all right. We present our systematic approach from artisan attempt to reproduce the legacy of trained samples from a generative model in the field of wireless communication research. We rewrite the entire framework from scratch with modern Python packaging. We rewrite with modern using. We re-implement the entire framework from scratch using modern Python packaging, dependency results, and the recent written command line interface. We find the biggest challenge lies in non-deep learning scientific software, because when trying to replace a MATLAB wireless translator with its Python open source counterpart, Siona. The entire process is currently uploaded as a YouTube series. The entire experience is recorded and will be uploaded. We can lay off the YouTube a bit here. Well, let's not lay off the YouTube. Fuck it, we're going all in. Okay, CCS concepts, blah, blah, blah. Legacy scores a significant pain point for reproducibility, with many popular repositories still used as they are today. Still used as they are today out of force of habit. This is the case for Python, where dependency was fortunately, ever since modern frameworks, modern tooling like UV has largely solved these issues and enabled much more seamless dependency management. Our goal is to present documented systematic efforts to modernizing such a repository. We target the repository at 1 and associated publication in 2. Supporting its associated publication in 2. Okay, the repository is an application of score-based general models. We picked this particular application area and repository. We picked this particular area because it covers 3 aspects that are still very relevant today. Generating training data with scientific simulation, non-deep learning software, training a score-based diffusion generative model, generating so I should I got a cite NCSN here, right? No, it's song improved. Yeah, okay. Nah, I'm gonna cut this. Score based. Okay, let me go to Google Scholar. Oh shit. Score based generative modeling. Estimating gradients of the data distribution. This one I want. Okay. So let me cite song. Score-based generative models. Song. There, we give the guy more credit. All right, and where's multiple? Okay. Training. Generating synthetic using pre-training scientific domains where hyperparameters are sensitive to numerical variations. Our primary goal is to modernize the code base and make it significantly more accessible. We identify and tackle the following higher level. A cross-platform approach for dependencies should be fully resolved and have exactly specified versions. We want to emphasize exactly specified versions, ideally across all platforms. A research-friendly command line interface for the main applications. Powerful. Did I define CLI again? CLI? Yes. I should not define in the abstract though. Okay. We want the CLI to encode sufficiently many hyperparameters such that the user makes 0 changes to code. The key component for answering the first disregard is the Python dependency management software. We choose UV due to this powerful feature set in cross-compatibility platform. A first major advantage is that UV manages Python itself cross-platform. Oh, okay. Too many cross-platform here. Which relieves you having to track and refer to multiple Python versions installed on the same machine. The first work item was to refactor the code from loose, locate the root to a proper package store with functionalized modules in the DiSco-MIMO. This is augmented by running UV init, which moves all project packaging and dependency management further to the basic configuration on listing 1. Using all fields limited by the China package. Later limited, whereas limited by later limited by the Siona package. Another glaring issue with the legacy is that it heavily depends upon the repository in 12. Unfortunately, because not properly packaged, is not installable. It is not installable as a module. It must either be a Git, must either be submoduled using Git or hard copy, the latter of which is opted in the code base. Possible licensing issues aside, it significantly bloats the code base, with out of which only 5 are truly necessary. We solve this by forking and once again applying to properly package. Once this is done, we use UV's Git. Oh shit, where is the Git? UV's Git as a Git source dependency with this missing commit ID for our refactor, thus locking it down to an exact version in time without copying any files. In this case, is there a double space here? Well, there's a fucking missing comma. In this case, the fork of NCSN v2. No indent here. Because we also significantly deleted files from our fork, the remainder of the code depends on our PyTorch to pose no difficulties to UV's dependency solver. Okay. Mutually exclusive. The biggest running challenge is bringing all dependencies to Python world, given into Python, into pure Python, given that the legacy depends on MATLAB. We switch MIMO channels into the Siona library, a native. This brings another dependency challenge. The latest Siona version that we consider when starting this work was TensorFlow based, and its dependencies were incompatible with PyTorch. Does TensorFlow have a paper? I think so. Whoops. Let me play this. Where the heck is... Oh my god, where do I say PyTorch the first time? Here. Oh shit, I need to cite PyTorch too. Okay, how do I cite TensorFlow? Is there a citation? There's no way there's a citation. Like, this is... Well, I think I'm just gonna cite it myself then. I don't like this paper thing. So I'm just gonna do online, TensorFlow, comma, author beats me, title, we'll call it TensorFlow, title, URL, this one, last access today, an end-to-end platform for machine learning. I guess this is the title. Okay, so then I can cite TensorFlow. And how do I cite PyTorch? I think has a paper. I'm gonna cite this one, the big one, passkey. This one I am okay with citing. Where do I say PyTorch the first time? Blah, 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 blah. Here we go, PyTorch. Okay. All right. We're getting very close because I'm going insane. Let me download this again. All right, so where were we? Oh, here. PyTorch and Poison NumPy, one of the backwards compatibility issues. Fortunately, UV has a feature designed exactly for its case of form conflict. We use this feature to allow the Siona code needed. And there's a Oxford comma here to allow the and the score base code to coexist. Siona code needed to generate the training data and the PyTorch based score based generating code in two separate dependency groups. This is Torch. Okay. Torch in CSMV2 and NumPy Torch Siona RT. This is also delivering an 8% inference speed up for free. We use Omega Conf and Hydra to add a fully featured setup for 3 user data generation, score based and inference. I need an Oxford comma here, and inference, and sampling. In particular, we use structured configurations, not in separate. And the fundamentals for a click-to-run pipeline to generate training data, train tests from scratch, as shown by the 3 sequential commands in listing 4. Notably, we also parameterize all file inputs. No indent. Okay. Python, we make it a bit stronger. Let's see, Python, typing. Okay. Where did I put the typing? Strong recommended from a type hinting system. Footnote. URL. Typing. By adding pre-commit hooks. Let me merge these. We use rough. An interesting challenge, a non-trivial challenge we have to overcome is combining. Let me download again. Okay, we're getting really close now. Majority Finance takes a hit in favor of modernization, but the core principles behind. Okay, it's clear. Not it's. It is apparent that the two distributions are significantly different. Despite our best, we're going to reconcile. Moving past the train distribution gap, figure 3 reveals another interesting. A lowercase we found that Scorb is highly sensitive and exhibits a dual mode behavior. Uncovered when inspecting legacy. The each report uses hyperparameter values related to the sampling process. Ah, shit. Despite the 3 orders of magnitude, we find that both systems. Modernizing legs up to parts 40 hours and took 40 man hours, 40 human hours, and was recorded and will all be released as a multi-episode. Most difficult part was reproducing the sampling algorithm because of its high sensitivity to the microprocessor and misdirection in the original, which deviated from the associated paper. Additionally, we're not able to overcome the caps by matching as many. Despite the differences, Training score was successful. Arguably very successful. Another improvement that was applied and not discussed in the bullet was that we were able to support for neural network backbones in the popular diffuser library, finally breaking away from the NCSN v2 architecture. Those which worked research by architects and prevalence certification score, in particular, March was in the original paper. We hope this experience was useful. We hope the general learnings about UV and modern Python tooling are also useful to the machine learning research community. I think this is it, guys. All right. Okay, this is it. We're done. Okay. Well, that was it. This was the series for a while. Thanks a lot for watching, for sticking around. We got the paper. It's pretty well proofread. It's a small paper, 4 pages. It's pretty crammed, which is good. You know, you always want to write about stuff. 4 pages, 3 figures, a bunch of practical code stuff, and of course, the whole repository will be open source. I feel like this is not even like worth mentioning, but okay, I gotta say that somewhere. The modernized repository will also be open sourced under a permissive license. There we go. So this should make us rock solid now, right? Of course, we were not able to... Okay, let's see if we cut this line. Yes, we were. Okay. That's it. How about we group these two? Let's see what this takes us. Nah. Now we're super tight here. This is it, guys. Okay. Thanks a lot for watching. Thanks for all the follows. Subscribe to the YouTube. We may take a break for a while, but you know, I'll have a lot of episodes to cut and edit. So this was it. Thanks for all the support. See you next time. More coding. Maybe another project. All right.